So we're into 3.2, investigating quadratic functions in standard form part 2 today, and that's on pages 163 to 179 in your text. Our curriculum outcome is the same. It's 20.7 to demonstrate understanding of quadratic functions of the form y equals ax squared plus bx plus c and of their graphs, including vertex, domain and range, direction of opening, axis of symmetry, and x and y intercepts. Our lesson objectives: number 1, to be able to find the x-coordinate of the vertex when a quadratic function is in standard form. Number 2, to be able to interpret the graph of a quadratic function. And number 3, to be able to write a quadratic function to model a real-life situation. So it would be nice if we could find the vertex of a quadratic function when the function is written in standard form instead of vertex form. And to do this, we're going to start with the function in vertex form and then expand and compare it to standard form. So here's our quadratic function in vertex form. So when I say expand, I mean we're going to have to square this binomial, multiply by a, and then add q. So if I do that, if I expand the binomial, that means I get x squared minus 2xp plus p squared, and that's just from knowing how to square a binomial, and then we still have a plus q. If I multiply that in, I get ax squared minus 2axp plus p squared plus q, and then finally I'm just going to rewrite it as 2apx plus p squared plus q. So knowing that standard form of a function, quadratic function, is f of x equals ax squared plus bx plus c, that means that I can say that b is going to be the same as negative 2ap. So b is equal to negative 2ap. Now the other thing I know is that this value for p is actually equal to the x value of the vertex. So that means if I can solve for p in this little equation, then I can actually find the x value of my vertex. So to solve for p, I just divide both sides by negative 2a. So now I can find out the value for p, and that is just going to be b over negative 2a, and that is the x value of the vertex. And this is what we've been wanting to find. So we can actually find the vertex by having a function in standard form as opposed to vertex form. So after finding the x-coordinate, you could easily find the y-coordinate by substituting this x value in, so whatever b divided by negative 2a is, into our original function, and that's how you would find the y value of your vertex. So your turn. It says a diver jumps from a 3-meter springboard with an initial vertical velocity of 6.8 meters per second. Her height, h, in meters, above the water, t seconds after leaving the diving board, can be modeled by the function h of t equals negative 4.9 t squared plus 6.8 t plus 3. Part A says graph the function. So I graphed it on desmos.com, and here's what I got. I put in all the major points that we need to take a look at. And part B, what does the y-intercept represent? Well, the y-intercept is right here, it's 0, 3, and that would be the height of the springboard. And that is when t is equal to 0. So this is h over here, or h of t, I guess, and this is t. So this is the height of the springboard, and that's what the y-intercept represents. What maximum height does the diver reach? Well, we can read that right off the graph. The maximum height would be the y value, so the maximum height would be 5.359 meters. When did she reach that height? And that would be after 0.694 seconds. D, how long does it take before the diver hits the water? Well, that would be when the height is equal to 0 again, and so that would be 1.74 seconds. E, it says what domain and range are appropriate in this situation? Well, our domain here is, we're talking about a real life situation, and we're talking about it in terms of time. So time starts at 0 and it goes as far as 1.4. So we could go x, and we could say, or I guess this is time, so we'll use t instead of the variable x. We'll say from 0 to 1.74. That would be for domain. The range is going to be h of t, and that is from the maximum height to the lowest height. So the diver goes as high as 5.359 meters and as low as 0 meters. So we would then say that h of t is between 0 and 5.359. So part F says, what is the height of the diver 0.6 seconds after leaving the board? So on this particular graph, we have time, which we know, and h of t, which is height. we'd have to estimate where 0.6 is. So what we're going to do instead is just plug 0.6 into our function, because we know that the time is 0.6 seconds. So that means we're finding h of 0.6. And that is going to equal negative 4.9 times 0.6 squared plus 6.8 times 0.6 plus 3. And when you do the math and make sure you follow your order of operations, you get a height of 5.316 meters. So that would be somewhere around here. It would be around 0.6 seconds. And here's our final example. It says at a children's music festival, the organizers are roping off a rectangular area for stroller parking. There's 160 meters of rope available to create the perimeter. So it says write a quadratic function in standard form to represent the area for the stroller parking. So two keywords I've seen already, perimeter and area. So right off the bat, we can make an equation for the perimeter. But I'm going to start with just drawing a quick little diagram. We've got a rectangle. I'm going to call it the two sides x and y. I know the perimeter of this thing, which is 160 meters, would then be 2x's and 2y's. So 2x plus 2y. Now part A says I need to write an equation to represent the area, and it has to be a quadratic function in standard form. So I know that the area is going to be x times y. Now, in our function, we can't have two different variables, x and y. So that means I'm going to manipulate the first equation, and I'm going to solve for y. So when I plug it in here, I'm going to have an x here, and I'm going to be multiplied by something else with x's in it. So by doing that, if I move the 2x over to the left-hand side, I get 160 minus 2x equals 2y. And then I can just divide both sides by 2, and I get 80 minus x. So that means my area equation is x times 80 minus x. Now, it says that I need to write this in standard form. So that means I need to multiply this x in. I can write this as a function a of x, because the only variable I have in here is the variable x. So I get negative x squared plus 80x. So there's my quadratic function in standard form. Now part B, this was part A, part B says we need to find the coordinates of the vertex. Well, we don't have a picture of this thing, but we do know that the coordinates of the vertex is p, the x value anyway, and that is negative b over 2a. We learned that today. So that means negative b is negative 80 over 2 times negative 1, which that means it's just 40. So if p is 40, then I can find out what the other variable is by substituting that into my original equation. So my original equation right here says that if I plug in a 40, I get negative 40 squared plus 80 times 40. Negative 40 squared is negative 1600 plus 3200, and that means that my area is 1600. So my vertex is at 40, 1600. Now it says I need to sketch the graph for the function that I determined in part A. Well, here's my function. I know it's a parabola that opens downward, and I actually know the two x-intercepts, because in factored form, we learned this last semester, in factored form, my two x-intercepts, there's one of them, and this is going to be the other one. So if I'm sketching a graph for part C, I know that my one x-intercept is at 0 and the other one is at 80. And it's a parabola that goes up and then comes back down. I know that the vertex here is at 40, 1600, and I guess that's another way that we could have found this other x-intercept, is that we know that the one x-intercept is going to be 0 because of this factor here. The other one is going to be the same distance away from the vertex as the first one was. So since the vertex is at 40, that means the other x-intercept is going to be at 80. All right, so there's the sketch of my graph. And now I need to determine the domain and range. Well, the domain of this function is the x values. So that's going to be, we use the variable x, so we'll do that. And we know that's from 0 all the way to 80. Now, because it's a real life situation, I actually can't have 0 or 80 included in this case, because x was the length of rope along the two sides. And if I had a length of rope that's 0, then I don't make a rectangle anymore. And if I have a length of rope that's 80, if this side's 80 and this side's 80, then there's no length for these other two sides. So it wouldn't be much of a roped off rectangular area for stroller parking. So in this case, I can't include the 0 or the 80. Now the range goes all the way, and we called that a of x because that was the area, and the range goes all the way from 0, you can't have an area of 0, so we won't include that, all the way up to an area of 1600. But we can include that because that would be if your x value was 40. Now if your x value was 40 and your area is 1600, that means your y value is also going to be 40. So we're looking at a rectangular plot that's 40 by 40, so it's actually more of a square. So in summary, we can find the vertex of a quadratic function when it's in standard form, and the way we do that is we use this concept that p is negative b over 2a, and after you figure that out, then you can plug it back into the original function and find out what your q value or the other value for your vertex is. You also need to be able to interpret the graph of a quadratic function in order to answer questions about it. So you need to be able to read numbers off the graph and especially pay attention to how the axes are labeled. And you also need to be able to create your own quadratic function based on information you are given. In order to do this, you may need to create two equations and substitute one into the other. So your assignment is on pages 174 to 179. Good luck, and we'll see you tomorrow.